Okay, this is sample problem 3.1. Calculate the molecular mass or the formula mass as appropriate for each of the following compounds. A is propane, which has a chemical formula C3H8. B is lithium hydroxide, which has a chemical formula LiOH. And C is barium acetate, which has a chemical formula Ba, parentheses, C2H3O2, close parentheses 2. Okay. By the way, the square brackets that you see with the barium acetate, that's just there for the editing purposes. It's not a chemical meaning to that, to the square brackets. Okay. So let's try number A. First, let's decide whether it's a molecular substance or it's an ionic substance. So A is propane, which is C3H8. It has carbon. Carbon is a nonmetal. It has hydrogen. Hydrogen is also a nonmetal. Two nonmetals, so that would be called a molecular substance. Now, because it has two different elements, carbon and hydrogen, that makes it a compound, so it's a molecular compound. So if it's a molecular substance or a molecular compound, we're going to calculate what's called the molecular mass. Okay, so we look up from the periodic table. Remember, you're going to get these numbers from the periodic table. So practice doing that. Practice pulling up your periodic table and finding these atomic masses. These are what we're going to use to do the calculations. Carbon is 12.01 and hydrogen is 1.01. Okay? How many carbons are in one molecule of propane? Looks like a 3, right? You see a 3 there next to the carbon, and then there's 8 hydrogens. So the molecular mass is going to be, let me write it here, molecular mass would be 3 times 12.01. Remember the units are AMU? And then 8 times 1.01. So that comes out to what? 44.11 AMU. Okay? So that's a measure of how much one molecule of propane weighs. So propane has 3 carbon atoms and then 8 hydrogen atoms arranged like so. So the carbons are in the center there, right? C3H8. So each atom has a weight, each atom has a mass. Add them all up, you get 44.11 AMU. Okay? Let's try B. Now B is lithium hydroxide, LiOH. This has lithium, which is a metal, and oxygen and hydrogen, which are nonmetals. So a metal with a nonmetal. Remember, we call those ionic compounds, right? This fits into that category of ionic compounds because lithium is a metal. Remember, the metals are the first 2 columns in the periodic table, and then the elements in the middle, which are the central elements there, which are called transition metals, and then a few over to the right. Usually the periodic tables are color-coded so that you can see which ones are metals and which ones are nonmetals. Okay, so that means, really, for our purposes, that just means we're going to calculate what's called the formula mass. The distinction there is that this is an ionic compound, so we call it the formula mass. And the reason for that is there are no actual lithium hydroxide molecules. They form these very complex structures, so we just figure out how much the formula weighs, or what the mass of the formula is. So we look up lithium. Lithium is, again, we're going to use the atomic masses, 6.94 AMU. Oxygen, 16 AMU, and then hydrogen, 1.01 AMU, right? Does that make sense? Okay, so now let's add them up. There's one of each. So it's 1 times 6.94 plus 1 times 16 plus 1 times, let me erase that. 1 times 1.01 AMU. Okay? All right, well, we could figure that 17 plus 7 is 23.9 23.94. I guess that's, oh, it's 23.95. But let's check. Let's go to a calculator. I'll clear this out. So 1 times 6.94 plus 1 times 16.00 plus 1 times 1.01, 23.95 AMU. Okay, easy enough, right? So the formula mass of lithium hydroxide is lower than that of propane, C3H8. So let's do the last one. The last one is the most complicated one. It's barium acetate. The acetate is a polyatomic ion. So Ba, again, the square bracket doesn't have any chemical interpretation here. It's just there for editing purposes. So what does this have? It's 2 acetates connected to a barium, right? It's useful to think of it that way. There's a metal, and this is a polyatomic ion. There's 2 of them, but this is essentially nonmetals. So this is an ionic compound. Again, there's more than one type of element, so it's compound, and it's got a metal and a nonmetal, so it's ionic. So we're going to do the formula mass. Okay, so we have to look those up. If you look up the atomic mass of barium in your textbook, you'll find that it's 137.3. So barium, 137.3. And then you look up carbon, 12.01, hydrogen, 1.01, and then oxygen, 16. Okay? And then you add them all up. Now, there's a couple different ways you could do this. You could figure out how much one acetate weighs, add those up, the carbon, hydrogen, oxygens, multiply that by 2, and then add that to the barium. Or you could use the subscript here times that subscript, this subscript here times this one, and then this one times this one to figure out each element. I'll do it that way. I'll do it the second way. So 1 barium, 1 times 137.3. There's 4 carbons, right? Each acetate has 2, but there's 2 acetates, so that's 4 carbons. So 4 times 12.01. There are 6 hydrogens, 3 times 2. And then there are 4 oxygens. Okay, so that would be equal to 137.3 plus 48.04 plus 6.06 plus 64.00, right? Of course, those are all in AMU. So if you add these two together, you get what, 70.06? And if you add these two together, well, let's go ahead. I'm just going to go ahead and make a little space for myself up at the top. It's very easy to make mistakes when you're not using a calculator. Of course, you can use your calculator. Okay, so let's just go ahead and add these up. 137.3, 48.04, and then 70.06. So 0, carry a 1, so that's a 4. And then 8 plus 7 is 15. That's a 4 plus a 4 is 8. 15, carry a 1, and it's 255. Is that right? Looks pretty good. That's about 255.40. There is a Sig Fig issue here in that this one only goes out 1 digit past the decimal point. And so since you're adding numbers, you only go as far out as the one that goes the fewest spaces, which is the 3 there. So it only goes out 1 digit. So really, we should round it to 255.4 AMU. Okay? So let's just do a little check. I did the arithmetic there on paper, but let's make sure that we get that right. So I'm going to come back here. So 137.3 plus 4 times 12.01 plus 6 times 1.01 plus 4 times 16.00. Oops, let me try that again. 137. See how you can easy to make mistakes, right? Plus 4 times 12.01 plus 6 times 1.01 plus 4 times 16.00. 255.4. So it seems to check out right there, 255.4. Okay, so looks like we got that one done right there. Okay, so there's one example. Make sure you practice as many as you can. That's called the either the formula mass if it's an ionic compound or the molecular mass if it's a molecular compound.